Okay, so perhaps it's time we should begin. You guys are okay with that? Yep. All right. You're excited, right? Yes. Okay. All right. That's what I want, an excited audience. Here we go. So how many of you guys were here when I used to run this? Oh, look at, oh my gosh. Okay. It was 5 years ago, but it feels like a number of centuries ago. Yeah. We won't go into why, but anyway. All right, so, all right, we'll begin. So I would like to start by acknowledging that the land on which we gather is the traditional and unceded territory of the Kanien'kehá:ka. You ready? I don't know if I did that right, but or the Mohawk, a place which has long served as a site of meeting and exchange amongst nations. All right. Sorry, I'm gonna try not to get out of hand here. Okay, so I'm going to try to give you some background to what's going on here tonight. So for starters, it's the Jean de Grandpré Distinguished Speaker Seminar Series. This series was launched in 2013. It was established to honor Chancellor Emeritus M.A. Jean de Grandpré, who was Chancellor from 1984 to 1991, a long-standing member of the McGill Board of Governors, and one of Canada's most distinguished business leaders. They're here somewhere, right? There you go. I was guessing somewhere nearby. All right. Okay. So first, I'd like to thank you and your family for attending. So, mine as well. All right. So, Faculty of Agriculture and Environmental Sciences is the steward of this lecture series. The faculty's mission is to produce and share knowledge, and in doing so, it promotes innovative research and educates the next generation of leaders while working to discover sustainable solutions for tomorrow, and as much as possible, thinking beyond the limited horizon of our own discipline, bridging conceptual boundaries and connecting dots between research activities and broader contexts such as social impacts. And we get to talking and discussing and thinking about AI, the potential social impacts are obviously pretty huge. This year, we're celebrating the 20th anniversary of providing this timely address to science topics to our community through the Food for Thought lecture series. So this is the one way back when. Food for Thought is proud to support the Jean de Grandpré Speaker Series, and I must say I am delighted to moderate it today. It's been a while, so I missed you guys. So, all right, there you go. All right. So this series was established at the instigation of then Dean Deborah Bazard, who, like to say, who convinced me. It took a certain amount of convincing, but she was pretty good at it, and the role of dean didn't hurt. So she convinced me to initiate it it is a far-reaching lecture series with annual themes based on current developments in science, including their technological and social ramifications. So I ran these series for the first 15 years, but eventually, and regrettably, was forced to give it up because of expanding academic commitments. During the first Food for Thought, during that time, Food for Thought dealt with issues around global food security, energy, sustainability, and environment, future challenges to agriculture, and on and on. And those of you who were at many of those remember there's some good stuff. So last year's theme was genetically modified organisms, and specifically around the issue of labeling. So you should know what you're eating, right? I think that's fair. This year, we're discussing artificial intelligence. I need some of that soon. So I'm just getting older. I'm getting older now. I need some. I could do with a memory transplant right away. So this year, we're discussing artificial intelligence and humanity. We're looking forward to a lively discussion, not only from our panelists, but also from the audience, right? So the pressure to perform here is, we're being very democratic about it, it's shared. So everybody gets a piece of this, so. Okay, so I'd like to start by, well, this year we're just, okay. Well, I want to start by welcoming you all. And by way of setting the stage for the town hall, this is a town hall style meeting, I'd just like to note that we will explore things like the definition of artificial intelligence, what can an intelligent machine do? How can we recognize artificial intelligence? When is a machine smart enough you say, okay, now this is artificial intelligence? Is there a boundary between mechanical tools and smart technology? So, other sorts of questions. We will explore things like the role that law could have with respect to artificial intelligence. What's the role of artificial intelligence in shaping social behavior? Is there a place for artificial intelligence in disseminating justice? I mean, that's it's pretty heavy duty, right, when you think about social context. So the first to address this will be Doina Prickup over here. She's telling me I pronounced her name semi-correctly. All right. So I'll introduce Doina now. Her teaching and research focus on AI and its applications. She leads the Montreal office of the AI firm DeepMind. Kind of interesting, right? So DeepMind is owned by Google, not a small entity, right? So they're big in my life, I'll tell you what. So she works conducting fundamental research on reinforcement of learning at DeepMind, in particular AI applications in areas that have social impact. She's interested in machine decision making in situations where uncertainty is high. Uncertainty, anything to do with me, my wife will tell you. But anyway, okay. So she's also the co-founder and advisor of the AI for Good Summers Lab. It's an organization that aims at getting more women into the study and work associated with AI. At this point, Doina, I'd like to turn things over to you for okay. So she's going to educate us. Okay, I'll try. This should be on.
Thank you very much, Don, for the invitation to speak here, and thank you to all of you for coming. Just a quick show of hands. How many people here are excited about AI? Okay. How many people here are really afraid of AI? Okay, good. That's good. So at least everybody's more or less engaged. That's good news. Okay, so I got into AI because I was very excited about it. I was very excited about it because as a kid and as a teen, I really loved sci-fi. And so, my idea of AI was like robots and androids and helpful things that get people to do interesting stuff, and that, sometimes they're also funny and explore that in their own way what humanity is, like Data in some of these Star Trek episodes. It's not exactly what AI is today. However, AI is becoming more and more pervasive in a lot of applications that touch our lives, like self-driving cars, not on the roads yet, but, sometime not too long, they will be out there. Also, of course, assistants, like the ones that you have on your phone that you can talk to, and, they're kind of annoying, sometimes funny, right? But they can certainly help you with certain tasks, retrieve information for you, and so on. And I think in the research community and in the industrial community, there is actually a sense that we are at a sort of a tipping point, in the sense that AI is bringing about something of an industrial revolution. Previous industrial revolutions have replaced or have extended humans' mechanical power, right? We can run faster, right, by using cars, and we can fly using airplanes and things like this. The AI revolution is much more about boosting cognitive power and providing tools that can help us achieve more and more interesting cognitive tasks. And so there is a sense that a lot of sectors of the economy will be touched. Some people are very excited by this. Some people are afraid of the change that is coming. So what I want to tell you today a little bit is about a piece of this artificial intelligence puzzle, which is machine learning, because that's my research expertise, and also because it turns out that in recent years, that is the subfield of AI that's kind of the linchpin of this puzzle, and that's the one that's expanded the most. So before I go there, I just want to mention, why is this excitement about AI happening now? And in some sense, this is not new. AI has been around since the beginning of computers, right? Back in the 50s, Norman Wiener and people like that thought about building intelligent machines, and that was part of the motivation for building computers in the first place. One of the things that is different these days is that we're really faced with an explosion of data that is coming from all kinds of devices, our smartphones, our social media, but also from physical devices that are connected to the internet, right? MRI scanners, sequencing machines, telescopes, machines that are on the factory floor that have all kinds of sensors on them that are measuring stuff all the time, right? And so there's just a deluge of data that we have to deal with, and it's complicated to deal with it without having some powerful automated tools. And so AI has come in as one of these kinds of tools. The other aspect of this, there's a graph here that's actually a log scale graph. It's not very clear for the axis. I apologize for that. But it's basically showing you the amount of compute that you're getting per dollar, right, over time. And that's a log scale graph. So basically, compute is becoming very, very cheap, right? You're carrying in your phone way more compute than has taken us to the moon, right? And it is very cheap. It doesn't cost the the billions of dollars that it used to cost. And so we have, on one hand, a big need to munch a lot of data. We have, on the other hand, some really powerful, cheap tools. And so that's where AI comes in this sort of environment to kind of put things together and help us deal with this data. Now, as I said, I work in a field that's called machine learning. That's about making computers sort of acquire expertise by looking at data. Some of the classical work in machine learning, and perhaps most of it, is what's called supervised learning. Supervised learning basically means we have to teach computers by providing examples where the right answer is known. Okay, so something like this, you have an image, we want to teach the computer about recognizing human faces, and so somebody has annotated this image by putting like little rectangles around the faces. Now we can take images like this with the correct labels, we can feed them into a computer, and we can have the computer try to figure out how to label new images, okay? And so, that's what's called supervised learning, and this has been around for a very long time, more than 50 years. But one of the interesting new techniques that have been sort of developed quite a bit in recent years is what's called deep learning, okay? And so, there's a little bit of controversy around this word deep, but this is the terminology that people use. Deep learning is essentially trying to build systems that consist of small computational units, a little bit like neurons in the brain, okay? So these are these little circles over here. Think of them as like very simple functions, something like a line with a threshold on it, okay? So each of these units is very, very small, but we put very many of them together, right? Millions of them together in layers. And they're connected by parameters that can get tuned by seeing data and by learning from this data. Okay, so really the power is in these connections between these different units that get tuned automatically. And so the idea is, for example, if we're trying to teach a network to recognize faces, we might feed it examples of images. In these images, somebody has annotated the faces. That's the correct answer. And the computer is going to be rewarded for giving the right answer, the answer that matches the annotation. And if the computer doesn't give the right answer, there's going to be an error that gets generated, and the computer is going to use that error to tune its parameters so that the next time it gives the right answer. Okay? And so we do this with lots and lots of data, typically millions of examples, okay, which we now have because we have so much data. So this particular example is what's called a convolutional neural network. It's particularly useful for images. Sometimes people say, well, it's kind of scary because it looks like a brain and it's kind of a black box and we don't understand what it does. But actually, we can examine what these little units do. Okay, and it's a little bit interesting. So some of these units learn, for example, to recognize edges and edges in different orientations. That's a little bit like what the visual cortex does in early layers. It has edge detectors. There's some of these nodes that get tuned, for example, to recognize elements of faces or even sort of contours of faces. So we have a node there that's a face node that lights up whenever there's a face in the image, just about anywhere in the image. Okay. There's also a cat node. Now, you might ask, why is there a cat node in a network that's supposed to recognize faces? Okay. Well, that's because a lot of the data that we use to train these networks is taken from the internet. And the internet is full of cats and dogs. And so these networks are amazing at recognizing cats and dogs, much better than at recognizing people, actually. Okay. So this is kind of cute, but it does make an interesting point, which is that whatever the system learns reflects the data that is fed to it. Okay. So it's not just that we have an algorithm that's a really good algorithm. We need to feed it good data in order to make sure that the system learns what it is that we are really trying to learn. Okay? And if we don't have good data, if the data is somehow biased, right, in a bad way, it's not reflective, let's say, of the population at large, then we may actually get spurious results. Okay? And that is a big problem that people actually in the research community think about a lot. Okay, now what can we do with supervised deep learning? Well, we can do very good image recognition, actually. This was really driven by the creation of a very rich data set called ImageNet, which contains 1 million images and more than 1,000 labeled object categories. Right? So people labeled all kinds of things in these images. And around 2015, these deep nets have reached human-level performance on this data set, not by using particularly new algorithms, but by sort of a marriage of some existing algorithmic ideas with some very clever computational ideas and with what people call graphics processing units, okay? Those are chips that typically people use for gaming devices, okay? The computers that you play video games on all have GPUs in them, and we've sort of repurposed them for the purpose of learning these AI models. So the fact that computers were able to reach human-level performance on this very large, very rich visual data set is really what triggered a lot of interest actually from the industry side in these kinds of technologies. And a lot of the giants, Google and Facebook and so on, have started actually going very heavily after this technology and trying to understand how to make it better and how to also include it in products. Another place where there's been really a revolution is speech recognition. Okay, I don't know if any of you tried to talk to a computer back in the 90s or the 2000s. There were speech recognition systems for many years. They were extremely bad. Now speech recognition is much better, right? You have devices probably in some of your homes. You can talk to the device. It doesn't always recognize what you say, but that's actually, reasonably good. Not good enough to carry a conversation, but just the speech recognition part, recognizing what you are trying to say, is actually quite good. And so again, so this is error rate, right? You see this curve going down and going down very dramatically around the time that this deep network technology has come online. Okay, so what else can we do? There's sort of, supervised learning is interesting. We can do very well at it, but it requires human annotators. It requires us to label data with correct answers. There is a dream that if you had an AI system, it would just sort of learn by itself, right? Just by observing patterns and trying to figure out what these patterns are. So that's a subfield that's called unsupervised learning. Means we get just data, like the trajectories that are there, and we give them to a system, and we like the system to find some interesting structure in this data. Okay. Now, if you're faced with just these trajectories and you're asked what's interesting about them without knowing anything else, like what's this information going to be good for, it's kind of hard to tell, right? These trajectories are similar in the sense that in both cases they're periodic, okay? But also they're kind of different because on one side they're smooth, on the other side they're spiky. So what's interesting about them? And so it's kind of an ill-defined question. Okay, now it turns out that this is actually accelerometer data taken from my cell phone. One case is taken from cycling. In the other case is taken from running. So you see these spikes when the foot hits the road. So if I knew that I wanted to do, let's say, activity recognition with this data, then the spikes would be quite important. But if I don't know that that's the purpose of analyzing the data, then it's hard to tell what's important. So unsupervised learning is conceptually very interesting, but it's hard, partly because we don't know what the goal should be. Okay, so I actually work in this field that's neither supervised nor unsupervised learning, which is called reinforcement learning. Okay, now just to give you an idea of what reinforcement learning is, I just want to have a show of hands. How many of you have kids? Okay, pets? Okay, spouses? Okay, so pretty much everybody has already run reinforcement learning experiments at home. Okay. That's the good news. So reinforcement learning is about teaching a system what to do by interaction, okay? And really the ideas have come from animal learning theory, back from Skinner, okay? That was the very origin of the idea, but it's been refined a lot since. On one side there, you see a little sort of biological reinforcement learning system. It's a little mouse that's trying to get to a food reward by pressing a sequence of levers. And now, of course, animals are very good at figuring out what they need to do in order to get to these kinds of rewards. This is exactly the principle that we're using to train reinforcement learning systems in the artificial world. We will have a system that's embedded in an environment. It'll have to be a safe environment, right? So typically it's something like a simulation. The system can see the state of the world, okay? It can take actions, and as a result of the actions, it gets some feedback, okay? But the feedback might be very noisy and it might be very delayed. Now, what's this feedback? It's really positive and negative numbers, and we program the system to want to get as big a number as possible. Okay, so the system wants to get its total reward be as large as possible over time, but it's allowed to experiment with the world, so it learns from trial and error, tries things out, observes the outcome, and tries to do more often the actions that are associated with good outcomes. And the other interesting thing is that, of course, the system needs to handle a dilemma, which is, should it always take the action that currently seems best, okay, or should it actually explore? There's a new coffee shop in your neighborhood, okay, should you try it out, or should you go to the old place that you know you like, you can meet your friends there, and all that? Well, it's not clear how to make that choice, right? And so sometimes, you know, in our life, we just randomize that choice. And so sometimes we randomize this for agents as well. This is part of the reason why they have to be in a safe environment to make sure that this is not a problem. Now, one of the perhaps poster systems of reinforcement learning is AlphaGo. This is actually a system that was developed at DeepMind before the days that I was there, but with a lot of interesting contribution for people who are trained in Canada, who are all highlighted there in yellow from the paper. And this is a system that plays Go. Go is an ancient game that is very complex, strategy game. And the system learns how to play this from interaction with an environment. So I'll just sort of give you a very brief idea of how this works. You have a system, it watches the state of the board. Okay, the state of the board is encoded in zeros, ones, and minus ones, depending on every square, whether you have no piece, the piece that you own, or the piece that the opponent owns. And you have one of these deep networks, convolutional neural networks, that looks down at the board, okay, and tries to decide what to do. But really, actually, we have two networks. There's one that's the decision maker, that's the policy network, okay? And there's one that's trying to evaluate how good a move is going to be. And so we train these two networks in parallel. One is taking the decisions, the other one is critiquing the decisions, saying, well, actually, you should not have done that, right? We're getting some error here. And so they're all adjusting their weights. The interesting thing is the reward is only received at the end of the game. And it's either +1 if you win or -1 if you lose. And there's no other rewards. So just from that feedback, the system can learn. Now, why can it learn? Because it actually can play lots and lots and lots of games against itself. Okay, so we have the system just sitting in a corner on a computer, mindlessly playing games of Go against itself, observing lots of different positions, trying out lots of different things, and learning from this experience. Okay, so Don is looking at me like I should be done. I just wanted to tell you something about where the frontier is, and I hope that this is actually going to help segue into Hannes's presentation. One frontier that I'm very interested in is whether a robot can learn to cook dinner, okay? And that's not just because I have 3 kids and a husband, and I'm really a very bad cook, okay? But actually also because this is a very hard task for AI systems, right? So when you think AI, you think, oh, you know, rocket ships and self-driving cars and things like this. Dinner is an extremely complicated process that involves physical interaction with the environment, a lot of uncertainty, you know, stuff is wet, it's slippery. You have to also make some high-level decisions like what kind of thing to cook, right? There may be things that fail, like, you know, you decide on a recipe and you notice you don't have a key ingredient, and so now you have to go to the store and get it and so on. It's very complicated, okay? We don't know how to make a robot that cooks dinner at all, okay? And so that's one thing that I'm interested in, and I'm working on. What we do know how to do is a lot of targeted applications. And so, you know, there are things like diagnostic systems for particular medical imaging tasks. We're quite good at that. There are things like support for elderly people to be inside the home, being monitored, right, being reminded to take their medication, all these kinds of things. We have a lot of that. There's a lot of AI research going into understanding climate patterns because we're all very concerned with climate change. It's a nonlinear dynamical system. It's very complicated, but we have lots of data from lots of different sensors, so it's pretty much the perfect problem to try and handle with machine learning. There are people who are looking into using AI systems for guiding the search for new materials, right? Simulating new materials, guiding the search for new drugs, right? Perhaps targeted drugs based on people's genetics and so on. So there's a lot of these interesting applications that would definitely touch people's lives, hopefully for the better. There are some kind of exciting and some kind of scary things, right? This is one of them, which is what sometimes people call learning to imagine, right? People in the literature call them more like generative models. So for example, you have some pictures there, right? They look like people, but they're not people. They're completely fake, okay? They are what people sometimes call a deep fake, right? It's a fake image that's generated by something like a deep neural network. And this network is trained to generate faces that look like famous people, okay? That's it, completely fake. There are videos of people talking online, giving speeches, completely fake, okay? Fake news is one example of that, okay? So that's kind of scary, okay? It's kind of exciting if you think, oh, we're trying to generate interesting things, do creative stuff, yes, but at the same time, right, there's a balance. And the last bit of frontier is having humans in the loop. And that's very much an open area, both for research, I think, in computer science, as well as research in other fields. How do we actually teach AI systems to do what we want them to do, right? Let's say they're driven by rewards. What kind of rewards, right? Who gets to choose the rewards? How do we understand what the system does? Right? Let's say you have a self-driving car, it has an accident. Whose fault is it? Right? How do we understand that? Maybe the car did something wrong. Is it the car? Is it the car maker? Is it the software maker? Like, whose fault is it? These are all very complicated, interesting questions that are going to require more thought. And so I'll leave you with that, and I'll hand it off to Hannes. Thank you.
Okay, I would like to thank Dorna very much. Lots to think about. I'll do the best I can. All right, so the next person to address this is Hannes Westerman. He's a PhD candidate in artificial intelligence and law. I would not have seen this coming, but anyway. All right, at the University of Montreal. He works in the Cyber Justice Laboratory. It's an amazing concept, and is in charge of the Justice Bot project. I don't know. Which aims to enable greater access to justice through the use of AI. He graduated in 2018 from Lund University in Sweden with a master's in law, focusing on privacy. I'd say privacy and security be big issues for the next few decades, and big data, also a big issue, but one most of us don't think much about. He has an interest in active technology and programming, and participates in hackathons. I think I've been the victim of one or two of those. So. Yeah. And has worked in the development of several smartphone apps. It's an interesting thing. My phone, I'm quite convinced now, is smarter than I am, and maybe by a good measure. So, okay, so I'll now turn things over to Hans. So here you go, Hans.
Hey, thanks a lot for that introduction, and thank you for having me as well. So I will talk about, first, what is AI? Donna already touched a lot about that, so I'll be brief. And then I'll talk about some of the research in AI and law that we're conducting at the Cyber Justice Lab. But first, what is AI? And there's many different definitions here, but one I like because it's pretty simple is it's machines exhibiting signs of intelligence. Now, as you can see, this is pretty broad. Even in fact, a dryer that stops once your clothes are dry could be considered artificial intelligence under this. But there's kind of different concepts in AI that I think are important to distinguish. One of them being general artificial intelligence versus narrow artificial intelligence. Now, general artificial intelligence is kind of what you see in the science fiction movies, like robots who are as smart as humans, who can do almost anything that humans can. But I think what's important to keep in mind here is that we're not there yet, maybe. It's very far in the future. We don't really have an idea of how to get there at this stage. But that doesn't mean that AI isn't powerful. Oh yeah, and one way actually of telling whether we have general AI is the coffee cup test, which is a bit similar to the dinner test that Donna suggested, which is, could an AI or robot go into an unknown person's home and make a cup of coffee? Now, this is pretty easy for a human, but for an AI at this stage, it's impossible, basically. But AI can still be very useful, and that is in the field of narrow artificial intelligence. And that's AI that's focused on a specific problem and solving that. And there's kind of been two historic different ways of achieving this, one being expert systems and the other being machine learning. That's kind of the big thing now. And I think that's where I draw the limit between what is like a very smart technology and what's kind of mechanical tools. And the way I like to explain this is by asking, how do you explain a question to a baby? Say you want to teach a baby that knows nothing to compare apples to oranges. Now, one way of doing this, and that's kind of the expert system way, is teaching it a bunch of rules, saying, here's some rules that can help you figure this out. For example, is the skin texture smooth? If it's yes, then it's an apple. If it's no, then it's an orange. But now remember, what if an apple goes bad? Suddenly the texture isn't smooth anymore, but it's still an apple. And further, remember, there's an AI. It doesn't know anything, so it has no idea what skin is, what texture is, or what smooth is. So those get very complicated very quickly. Well, that's kind of the newer way, machine learning. I mean, that is, instead of teaching the rules to the robot, we let the robot figure out the rules for itself. So we show it a bunch of images, like thousands, and tell it, this is an orange, this is an apple, there's another orange, here's an orange. Once we've done this thousands or millions of times, the AI by itself learns what makes something an apple and what makes something an orange. And so after that, we can show it an apple, and we can ask, what is this? And it will apply those rules and say, this is an apple. And now with the new frontier of deep learning, this has become very good at recognizing images and speech and things like this as well. Here are some use cases. I'm sure there's many, many different use cases, and I'm sure you know lots of them. But one, for example, if you Google something, there's AI going on there figuring out what you want to see, what's relevant to you. Deep or AlphaGo, as we spoke about before, is very good at playing board games, way better than humans, and maybe self-driving cars in the near future as well. Now, this could lead to the kind of disruption of several industries, things changing and stuff. And I think one of these industries could be the field of law, and that's where my research comes in. And there's kind of two main connection points here that I see between artificial intelligence and law. The first being, should we regulate AI? And this is, AI has been used a lot in decisions that affect people deeply. So there's been a lot of thought being put into, should we regulate this somehow? What are the rules that we should follow? And Montreal is actually at the forefront here, with the Montreal Declaration of Responsible AI being launched recently, which sets out some guidelines for how to do AI responsibly. But then what I'm looking at is, how can we use artificial intelligence in law? And this is a big field. There's many very complex issues in law, and with AI we're not really there yet. But there's many other cases. So imagine, for example, you are a tenant somewhere, you rent a home, and you come home and it's just a mess. There's bed bugs, there's water damage, and you ask yourself, is there something you can do about this to get damages or to terminate your lease? But you look on the internet and it's very unclear. It says, for example, your apartment has to be in a good habitable state. But it's not really defined anywhere what exactly does that mean. If you have water damage to your furniture, is that a bad habitable state? And this is a pretty common issue. 50% of Canadians will encounter a difficult legal issue in their life, but only 7% of those actually go to the courts to solve these issues. And unresolved issues can cost $750 million a year in Canada. And there's several costs here of going to court and being involved in a legal process. First, of course, monetary costs. It's very expensive to hire a lawyer. Temporal costs. It can take months or even years before you have your resolution. And the psychological costs. It can be, many people see this as being very stressful, it's complicated, it's very hard to know what to do. So this is kind of where I see one very interesting approach of AI coming in. How does this work? Yeah, there we go. So this is kind of an interface, how we imagine it could look and how it could support people. Let's see if it loads. Maybe. I'll just copy this instead. No, it doesn't work either. Okay, so here's how it could look. You enter this app or this website, you start a questionnaire, and it asks you kind of very simple questions. These aren't legal questions, but things like, do you feel like your apartment is in a bad state? And yes, in this case, for example. Then it asks you, are any of these present in your room? And here you could say, there's bed bugs in my room, for example. And based on this information, then asks further questions. How many are there? How long have they been there? And then it gives you kind of a list of similar cases and a curve of their outcomes. So it gives you an idea of what you might have access to, which legal remedies, and how much those might end up being. It could also tell you, show you some similar cases if you want to read, and it could give you more information on which next steps you have, and the legal basis, and so on. Let's go back to this. Great. And I think this kind of information has a lot of potential to support decision making, because people don't really have access to this information today. It's very hard it's expensive to hire a lawyer, and this kind of information can really support people in helping them figure out what to do. And it's also really interesting in the field of something called alternative dispute resolution, ADR. And that means that people might not actually have to end up going to court. Many legal issues might be the case because people just have very different expectations of how a legal issue might turn out. Maybe a respondent wants to pay only $100 versus a claimant who wants $8,000. But if you show them some of these statistics, we can potentially align their expectations further. And based on this, they can come to a settlement between themselves without having to go to the court. So I think systems like this can kind of increase the legal harmony between people. It can increase the social peace in society, and it can also reduce the kind of heavy workload that the courts are facing today. And it's also non-zero sum. There's no jobs that are disappearing because of this. It's only people that will get further help that they don't currently have. So I think many people look at AI as kind of the bad robot that will come and take over humanity. But I think a much more realistic and interesting way of looking at it is like a tool, like a hammer. Just like a hammer, AI is a very good solution to some problems. And it can kind of increase efficiency of humans in solving these problems. But it's not the only solution. If you're dealing, for example, with screws instead of nails, it's not the perfect thing, and you might hurt yourself. You can use AI for good and bad things, just like you can use a hammer. But all of these things have together that they're kind of, and I think that's what really makes us humans, is that we create the tools to enhance our own efficiency and to extend what a human is. And I think AI is kind of the last or the most recent and most exciting step in that journey. Thank you.
Okay, I'd like to again thank Hannes in this case for some very interesting thinking on all this. So we've covered a number of things. I think in general we've looked at we've considered things like we've looked at things that might at least relate to the main questions actually how artificial intelligence and how it could be integrated with humanity. This is a big thing for us. It appears that it's coming. So how can we integrate it with humanity and make it as beneficial and positive as possible? How do we understand the incursion of intelligent machines? Where is it going? Where is it going to take us, or will it harm us? Smart technology can save time and effort, so is this beneficial? Is it worthwhile? Can it assume human roles? I'm sure it will in some cases, but we're saying maybe not in the case of law. That's a good thing. Will we become integrated with the use of intelligent machines to the point where the line becomes blurred? Where all these things about can I get a graft, right? So can I get more memory? This is what I need more than anything else right now. What is our responsibility to understand how machine learning is integrating with us? Is there a cost to humanity and an impact on our understanding of self? If so, what can or should we be doing about integrating intelligent machines and humanity at a relatively early stage to avoid problems later on? There is just so much about this. Anybody here read The Economist? Yeah. So did you read this week? There's a nice thing on military and AI, right? Yeah, I read this in the middle of the night last night. It wasn't really a smart move, right? I'm reading this, and it's very technical, but you know, if you step back, you read a paragraph, you step back, ooh. Yeah. So anyway, it's interesting stuff. There's a lot of this coming. So we've gone through with our two speakers here. We've looked at Doina looked at AI and the potential industrial revolution of sorts based around this. Data explosion. Certainly, there's huge amounts of data being collected now, and a lot is being used to market things to us. Right? There's all of that, and deep learning, supervised, I guess, and unsupervised as well. So when I was doing a lot of child rearing, it was mostly unsupervised in our house, right? So it did lead to some problems later, anyway. And this whole thing about humans in the loop and how we do it, how they become more interactive with us. And we had the dinner test. Can you make dinner? And then we had the coffee test. For me, both of these are important, right? So key, starting the day, a little food, and caffeine. I have this saying I always say, where there's caffeine, there's hope. So it's pretty fundamental in my life. So Hannah has talked about what is AI and machines with significant intelligence. Where's the cutoff between just a kind of a machine that can do a few things and an intelligent machine? I'm sure anyway, I don't know, but this is going to be a big question at some point. Maybe a legal question at some point. Yeah. When is the machine responsible? This is going to be there are all these things coming. Yeah, machines. We were just saying they're not as complex as people yet. It's some distance off, but it's coming. All these expert systems, etc., that are based in machines, uses of all of these kinds of things in particular. And I like your business with the legal system, right? I spent a year in intellectual property litigation. I'm much happier if machines had done it rather than me. So, yeah. But anyway, so there's all these things out there. They're coming. It'll be extremely interesting. I think. How are you guys doing? Yeah. So I think where we are now, this is your turn. So does anybody have questions, comments, observations? Sorry? Yeah. Sorry, I need them up here. Yes, I do. Sorry. Thank you, Dinah. Yeah. Maybe I'll just stay here for now. Okay. All right.
From what I see, there are two main types of artificial intelligence machines. Sure. Yeah. We're recording, so we have to use microphone. Yeah, I can see there are two major types of artificial intelligence machines. Those that are made for mass production, like, for example, automated cars, and those that are made for customized applications. I can see for general mass production, it looks reasonable. I think it becomes economically feasible because the market is there. But my question is, for customized application, let's say for an organization or a paper mill, we're in the paper business, who wants a machine that can really makes intelligent decision. It would take, I think, a huge amount of effort to develop that specifically for a particular application. What kind of time frame are we looking at? And just as part of that, do you see a time when we will have also different IQ for an artificial intelligence, like a machine that is intelligent and one made by a competitor that is kind of dumb or less intelligent? That kind of thing.
Yeah, so that's a great question. For organizations, typically there's two things. One is there are AI services, let's call them, that actually the idea is they wouldn't be developed like in-house by the small companies or the medium companies. They would be really developed by AI providers, and then you can subscribe to a particular thing. So already, for example, there are services where, Google has trained image recognition systems, for example, right? So you can, if you want to use Google Cloud, that's one service that you can subscribe to that essentially says, in your company, you can do some image recognition using our network that was trained on lots and lots of data, and then a little bit of data from your side. So I think that's one direction that things are moving in, where there are several companies, Amazon's another one, Apple's another one, that are developing these services themselves. They have lots of researchers that are, that are trying to push the frontier to make these services reliable. And even in Montreal, there's a company called Element AI who does the same kind of thing, provides services to businesses that are not AI businesses, but that may want to use some AI, and they try to give just a little bit that you need. I think when it comes to physical systems, right, devices and robots, and then things are a little bit more complicated because you need some sensing capability on the machine, and then you need the connection to services. But even there's been quite a bit of development in terms of providing. So in the States, they have this word called flexible manufacturing. So there's sort of parts of robots that you can take and that assemble themselves depending on the task in sort of flexible ways. And if the task changes, it's easy to reconfigure things. I think it's going to move more and more towards that, just like it has with assembly lines, regular assembly lines.
Existing companies, for example, would have to evolve that way.
Yes. Yeah. Yeah, I definitely don't think that it's going to just be pervasive in all the companies, that everybody will have AI expertise. On the other hand, that does open up the need for companies to understand sort of what the tool is, and what it can do and what it cannot do. And that's a kind of education that right now is really lacking. And then we need to fill that gap.
I also really like this question, and I also think there is the question of kind of imbalance in AI, because as we've seen, there's a lot of big companies like Facebook and Google and so on that have a lot of data and a lot of expertise to create these tools, whilst others might not have the same possibilities, and that might be an issue for competition between companies and so on. But fortunately, the big firms have been very fair in sharing these tools and these systems. Not the data so much, but the tools definitely. So I think it is possible now, even though it's not difficult, for a smaller organization to create their own artificial intelligence as well and use that in their product.
Okay, we'll just go here.
I have the microphone.
Somebody has the microphone. Well,
I'm very impressed. I've heard the talk on artificial intelligence before, but always in the sense of the growing and the innovation and the breakthroughs. But I'm really quite excited to hear about the social side of this. And it jigs my memory here that what motivated the artificial intelligence movement was the gaming industry, which is motivated by money, which is motivated by who pays for these things. So it's a business-driven development process. My question comes to the social justice side is, and this is a very odd question for me to ask because I'm very over there, but the social justice side is who is championing the social justice development? Who is championing the AI technologies for homemakers or the aging population? Who's championing that social side? And then the second part of the question is, I think Quebec and Canada are kind of leading the way in this kind of stuff. And is there some positive things to say about what the Canadians are doing in the sense of the social justice?
Okay, that's also a really good question. Thank you. And I think there is quite a lot of this kind of championing for the social justice side going on. And I think that often comes from grassroots, as in people using AI and seeing the massive benefits it can bring, and then deciding, okay, I want to use these tools to increase social good. And there's a lot of conferences spring up in this area and inside of companies as well. I know that people are very interested in using these new tools to improve that. And as you mentioned, a lot of it comes from the state as well. And I think Canada has, and Montreal has become a very strong kind of center for artificial intelligence, partially based on that as well, I think. As you.
Yeah, and in fact, it's kind of interesting, but machine learning and AI have been sort of always at the forefront of doing things for free and trying to share as much as possible. So even back in the 2000s, we had the first sort of open journal that has no publication fee, no subscription fee, that is just online. This was the Journal of Machine Learning Research. At the time, publishing companies were really mad that we were doing this, but I think the community is very much into open access, open software, and open sharing. And the social justice is one example, but there's actually lots of these kinds of AI for good applications that people are interested in, including healthcare, including climate So trying somehow to contribute to that. There's a lot of, in the research community at least, there's a lot of emphasis on that.
I found someone.
Hello. Thank you for being here tonight. I had two questions. One is a legal matter. A lot of our reference books are now online, history of common law, and Wikipedia went down this week. So I was wondering where will all those references be if they're in these systems that are in the cloud and not accessible in physical form. And secondly, I'd be interested in what is going on in the plant science world in AI. I know we recognize a lot of plants with AI imaging applications, and what is the place of the botanist and where and then our tied to nature and how it will evolve with these new technologies.
Okay, I'll start with the legal question. I think that's also a really, really good question. I mean, legal cases and documents can have relevance like hundreds of years in the future. And I mean, what we're seeing now is, as you say, many of them move to the internet and are published there as kind of the main source. So, of course, it's super important for these publishers to maintain that continuity and have those things there. But, I mean, people know that this is important and interesting. So I think there are a lot of resources. Like keeping data up for a long time is something that I think is possible to solve using the tools we have today. And it won't always be perfect, but I think it's the legal publishers, I can't really speak for them, but I'm sure they have backups and ways of maintaining the service should something happen as well. But it's a very, very important point, I think, with much of this information moving to the internet and being very relevant for long in the future as well.
Okay, I'll attempt the botany part. Okay, so these are not two things you would think would be all that linked, right? But one usually thinks of plants as being not all that big on intelligence, but shouldn't underestimate them. But having said that, there's a lot of things happening in crop production on that side of it. So producing food, etc. There's now a lot of stuff going on with monitoring plants, monitoring crops, monitoring development, a lot of drones being used, etc., and a lot of sensors being used so that they can determine what's the state of the plant in terms of are they stressed and things like this. There's some interesting stuff going on right now. You know how it is with all this cannabis stuff, right? So yeah, so the thing is, if you work in plants over the last year or so, I'd say you will be approached by companies wanting to work with you on cannabis, and so now I am, and. Well, it's one of those things, you know. After a while, it's hard to say no to the money, so we're working on it, and I'm talking with some guys who are interested in working. It's another group that could be a company. They're not yet, but who want to work with the industrial partner I'm working with because they're working on sensors that can, among other things, potentially determine cannabinoid levels in living plants. So they can tell you if you're doing something with the plants that's going to shift cannabinoid levels. And obviously, the people who are growing these things are interested in this. It's economic, let's face it. So there are quite a lot of things going on in this, and as much as there'll be AI sitting behind that, you could imagine something where these sensors are measuring things in the crop, and once you understand what changes what, then it might be linked into something else that's then changing inputs into the crop and moving it ahead in the direction that people want it to go. Same thing is possible in the field, although it takes a while to get to that level of control outdoors. But anyway, so things are happening. I would say that the plant side is probably not the foremost field right now, but it's maybe in terms of that whole thing about making supper, it does have some relevance in the long term, right? So, okay, so that's it for me. Any other questions that are? Oh, there's so many. We have a person with a microphone. It makes them.
Yeah. Well, I have two questions. Probably only one. We'll see. The first one is more of a statement that I'll give, and you tell me if I'm right or wrong on that. And based on that one, you'll get the second question. Now, the first question, my assumption is that on all of those expert systems or AI systems, every single one of them, without any exception, are lagging behind a human being, like in the sense that there's got to be a human that is an expert, that somebody analyzed and came up with a way to represent it in a computer, and then the computer got better, and then it kind of closed the gap. But nonetheless, there's a gap. There's somebody brilliant behind every single of those systems. Am I right in thinking that way?
There's somebody, well, there's behind all those systems, there are many people that have come up with the techniques. But in terms of expertise in the target domain, there are examples where the computer is the best. So AlphaGo is one of these examples, right? It's the best Go player among people and computers.
Yeah,
and there are other examples like that, you know, some of them in image labeling and so on, where the computers are really the experts in the target domain. But yes, to build the system took lots of people to come up with ideas for how to do that.
Yeah, for AlphaGo, I'll check what you just said, because I'm a Go player, but I didn't know that AlphaGo was such a good system. Okay, so my second question then is that in terms of AI annihilation or integration, if we go on the basis, that's very close to what I said, that there's somebody expert in that area of awareness, and computers just to facilitate that knowledge to be known by more people. Well, the people who are afraid of that for the annihilation, even if there was no computer, you might be annihilated by somebody who knows more than you do. Right? Which means then you have to go that it's an integration solution, right? That, you know, we're getting towards integration, otherwise those guys will be annihilated. But if somebody is too clever in something nobody like, and he's hiding behind a computer, they'll find him and get rid of him, right?
That's a really good point. I want to go back to your first question as well. I think it's very accurate for expert systems that I talked about with the rules, but the new systems, I mean, sure, domain knowledge will help you, but it's not necessarily required, because the computer figures out the rules by itself. So it could see correlations in the data that no human could ever see.
Yeah, but the concept of right and wrong, where do you get it from if nobody knows it?
Well, there you
can you say the computer came up with something that is beyond what we thought of? Somebody has to agree and understand it, isn't it?
Not really. See, weather, for example. A right and wrong answer could be, will it rain or will it not rain? But that a human could give those predictions, but an AI can figure out the correlation between millions of different factors in patterns and potentially figure out will it rain or not based on better data. So it will be stronger than the human than predicting in that instance, will it rain or not? But I do think the point you raise about people hiding between AI is a very good one, because, I mean, there's many things that are going on and that AI could be used for, where people can kind of hide behind it and say, oh, we weren't sure the AI was going to do that, and kind of blame the AI for something that they actually want to accomplish. And one of those things could be, for example, say social networks that optimize your viewing hours. And in the end, they show you the content that makes you likely to view more and more. This is not really in your interest, because it's probably not going to be the most educational or interesting content for you, but it's very much in the interest of the company. And they can say, oh, this was AI doing this, we had no idea, whereas actually it's very much the goal of the company to optimize for that parameter.
Thank you very much.
Thank you. So as a major consumer of social media nowadays, this is something I think about more and more. But it seems we're entering the point now where we have algorithms and artificial intelligence that are on LinkedIn, and they're recommending us the perfect job, knowing us and our backgrounds. We're on YouTube. This is the next video you have to watch. On a dating site, this is the perfect partner for your life. And these are decisions that we're no longer making ourselves, because these algorithms and these artificial intelligence programs begin to know us better than we know ourselves. Is there a danger in that? Is there a limit as to how far we should go with that?
Yeah, so recommendation systems are one of these very tricky areas, right? Where on one hand, if you're looking for books or for movies, and if you have a really good recommendation system, actually, that'd be great, right? It'll shorten your search and you'll be happy and entertain and so on. On the other hand, you can definitely push this too far, right? And create these echo chambers, for example, where the content that you're being shown is all very similar and more extreme, and this is a phenomenon that's been documented as well. this is a problem that in some sense is, goes back to issues that are outside of AI, right? What is the goal of a recommender system? Some people have designed it for some purpose, right? And the system is doing its job, being good at that purpose. But it's really, it's the company, it's whoever has designed the system that has some goals in mind. And so that's where, at least in my mind, we have to think very carefully when we put these systems out there, what is it that we're trying to push them to do? And to also have sort of checks and balances, right? In terms of, having good judgment, for example, when you are on the internet and when you're getting recommended things is really, really important. Nothing is going to replace that, right? Just like when your friends are recommending you certain things and you have to use good judgment, it's the same kind of thing, right? Maybe perhaps on a different scale. But.
Yeah, I think I also definitely agree that it's kind of a social issue, and it's a lot about the scale. Because, before you could have, for example, newspapers that only targeted a certain audience and only showed that audience article from that perspective. And you could have, for example, say a person that only introduce you to their friends that they think you will like. But AI enables this to go on a huge scale. Millions of users and thousands of decisions a second. And I do think there is some danger here of those systems being too good and too personalized to a specific person, that they kind of lose the overall view that they maybe used to have.
Getting back to who's right, the AI or the person, I heard recently, I don't know, radio or TV, they were mentioning that perhaps for judges to eliminate their bias in making a decision on a court case, that they might have AI present to analyze everything, and that the judge could then listen to the AI's recommendations as well before he makes his sentence. How close are we to having that happen?
I think that's a super interesting question. And that's really a lot about what I think about. I think there's kind of two opposing viewpoints here. It's kind of a spectrum. And on one side of the spectrum is that every case should be treated absolutely individually. And that is, if a person has a different issue, that issue should be dealt with in their own way. The judge should be able to kind of free to decide how they want on that issue. On the other side, we also expect consistency. We expect similar cases to be dealt with in a similar way. No cases are, of course, perfectly similar, but we expect some form of consistency. We don't want one person to go to jail for 3 or prison for 3 years versus another for 20 years for the same crime. And AI is can be very helpful in increasing that consistency, because it can see factors, it can analyze those, and it can give you a prediction or show you similar cases. But of course, people would then argue that, well, this kind of removes the power of the judge to actually make the decision, because they are now under pressure from this AI that gives them a suggestion and tells, look, this is how previous judges reasoned, and they have to have kind of a reason to step away from this, which could also lead to effects that aren't that positive. And I also want to mention some research done by a man called Daniel Chen, who uses artificial intelligence to analyze legal decisions and to detect kind of if there's some factors that shouldn't be considered that are considered in coming to a decision. One such factor could be, for example, the political inclination of the judge, the time of the day, and such things. We don't want them to have an effect on the judge, because the law should be what comes to a decision. But using AI, we can kind of spot those. We can analyze a lot of decisions and see if there's something that affects the decision, which we might not want to do that. Now, this is very interesting, but I also want to say that this specific thing was very recently banned in France. You can now go to prison for up to 5 years for doing this kind of analysis on court data. So it's very controversial, but very, very interesting, I think.
There's actually been very similar findings in medicine as well. Like if you analyze, successive surgeries and so on, right? Day of the week and time of day matter. And this kind of analysis makes lots of people very unhappy. And so, yeah.
It's very simple, my question. Who and how is AI being regulated? It seems the free-for-all out there with big business, and you know, people count. So that's one question. How is it being regulated? Second one is, who's responsible for the social consequences of AI? The unemployment? Who's going to pay for that? We the people? Or the companies? That's it.
So I think there's a lot of thinking happening right now around these issues, around the social impact and how to mitigate that if there is negative impact, and around the sort of the regulatory system around AI. And the Montreal Declaration was actually a really good step and really put us at the forefront of this kind of thinking here in Montreal and in Canada. There aren't set answers yet, but these are questions that are on the plate of governments, you know, in Canada, in the US, in Europe as well. I think Europe is perhaps farthest ahead in as usual in terms of regulations, just also because they have lots of regulations surrounding data and the use of data and what it can and cannot be used for. So I'm sure that these things will be coming.
But there are many unethical, immoral. We all know what's happening. And there just doesn't seem to be any consequences. And it continues.
So I think, you know, going back to Anna's example of the hammer, right? It's a tool that can be used for good and can be used for bad and needs to be, you know, those purposes need to be understood. And I think it's just because it's a very new tool, there just hasn't been enough work done on the sort of on the ethics and law side of things, but it is coming. There's actually lots of people interested in this now.
But you know something, that maybe is the most important aspect. Not the gaming and making money, the advances. The people and the impact on the people should override.
Yeah, and I totally agree with you. This is partly why a lot of the thinking that's going on actually is in applications that would help people, like healthcare, right? And so that's sort of the way that we're thinking of handling it. But in terms of the regulatory system, you know, like I said, there is a lot of thinking around that, I think, in the legal and social science community at the moment. And I'm sure that more formal regulations will be coming in the years to come as well.
Yeah, and I think one of the regulations that have already started to come into force is the one in Europe, as you mentioned, of the GDPR, which says, for example, that each decision taken not by a human that will affect you to an important degree, you have to have the option of knowing how that decision was taken and also to appeal it so that a human can actually change that decision.
But it's not just that. We have an election coming up.
Yeah, I don't think there's any easy answers here, and I think many lawyers have to kind of, as it often happens when something new arises, lawyers have to consider when is the right time to regulate it, and how do we even regulate it? Because AI is something that is so new and developing so quickly that it can be very hard to figure out what it actually is, how to regulate it, should it be regulated, in which way should it? And we also don't want to prevent the amazing advances which can come from AI from happening because we regulate it too early and in a too strong way.
Yeah, and some of the thinking actually is being inspired by the regulations around genetics, right, and gene editing, which is, you know, very similar kind of thing, can be really good, can be really bad. It's a very controversial technology. There's been actually a lot of thinking in the legal and ethical field around that, and I think the AI community is trying to look very carefully at that and see what kinds of things we can borrow from that.
Okay, I'm just following the time here. That's my job. So, but so just maybe do 2 or 3 more questions, and then we'll saw it off. But yeah, we'll do a little wrap up. But anyway, carry on. Who's next?
Yeah,
somebody has a microphone. There we go.
Here I am. Doina, right in the very beginning, you asked for a show of hands about how many of us were excited and how many of us were frightened about AI. Well, we've talked a lot about all the excitement of AI. I'm one of the frightened people. And so is the lady in the corner over there. And then you showed us photographs of people that weren't people. And then we talked about speeches that are made by people that really aren't speeches. And we get into this whole era of fake news and all of this stuff that is coming in. And you use the word judgment. Yes, we have to use our judgment on whether to accept this as being real and valuable and how it affects us or not. Well, all of us in here, and I think there's a writ coming down, as you said, tomorrow morning on our election, and we're saying all of this is to come through. We can ask our social world to pass a law saying it is against the law to make a false speech or to represent it. We can do that. But there will be always people who will break the law. Are there some AI scientists out there that are working so hard to create an AI program so smart to be able to say, this is not real, and block it?
Yes,
Are we keeping ahead of the bad guys? It's a funny term, but are we keeping ahead of that?
Yes. So the kind of technology that produces these fake images, for example, is something that was actually developed. The idea started in Joshua Benger's group at University of Montreal, right? And it's a technology called generative adversarial networks, okay? And the basic idea is you have one network that's trying to make images, okay? And you have another network that's trying to detect whether this image is fake or real. And so the way you push the first network to make more and more realistic images is by correcting it, okay, with this discriminator that's telling you, you know, does this look like a face, yes or no, and they're both trained together, okay? But it's exactly that same kind of technology that can be pushed a little bit farther to say, oh, and by the way, this is a fake, and I'm now using it separately, right, on data that's generated to say this is definitely a fake. Now, this is being, there's lots of people working on this, and there's, you know, the results are quite good in terms of detection rates as well. There's also been a lot of thinking around various forms of watermarking, right? So that, and you know, it's not just that you have a detector to say yes or no, this is real or fake, but, you know, when there's a real speech, it gets watermarked, and therefore it's easy to expose, for anybody to expose whether the data is real or not. And I'm sure that is not sort of deployed yet, but that's something that, at least in the research community, people have looked at. And it would work just like the watermarking on paper, more or less.
Well, I hope the watermarking or whatever it is comes real fast before irreparable damage is done. I mean, we look at the election results over the world now and things, whether they're affected or not by false statement or fake news of things. And we're just, I'm afraid that Pandora's out of the box here. And I'm not sure how good we as a society, I don't care whether it's alcohol or prohibition or all sorts of these things that have become illegal, hasn't really stopped all of these things from happening to the degree that they can do real harm. And that's why I was on the frightful side of your original question.
Okay, we'll just take one last question.
So one thing going on that, is that a thing with AI though? Because it feels like images that are fake, we've been able to do that for a while. The thing is now we can do videos as well. Even though we had images before, there aren't huge things that people believe based on fake images, potentially. I think social context here is very important to change, that we realize, okay, videos can now be fake too. Maybe I should look at the source, I should look at the surrounding context as well before basing my opinion on that.
Can we give comments on what you just said?
Okay, one comment. Just
about fake imaging and all that. How people realize that take any dummies in the store, department stores that wear clothes, you know, and for women to buy, and if you measure their legs, like the femur, any part of the body, there's not a single woman in the world that would have these measurements. This is like a fake body to sell a product, has been there for 50, 60 years. It's not AI. AI just makes it maybe more accessible to people, but all that dangerous thing is happening by human beings before. They just have a tool to maybe use it more. So I'm not afraid of it. I mean, if I was afraid of it, I would be paranoid from day one. I trust human nature.
Can I just make a quick...
Someone with a microphone.
Yeah, okay, let's do the person with the microphone, then we'll let you, then we're done. Okay, go ahead. Who's got the microphone? Go ahead.
I'm worried my question is going to be mundane by comparison, but I had a question for Hans, really about learning. We've talked about how these learning systems are really dependent on data sets. And in the case of Go, you can picture that's a data set that's easy to code, or image data is easy to code. I'm curious about jurisprudence. Are these data sets that have been coded by people, or is AI at the point where it can read legal texts to infer the coding system required for the case?
No, it's not. That's a really, really good question. I think that's one of the really hard things about applying AI in law is that, yes, an image has something that is on the image. We can describe that, as you said. A Go game can be won or lost. But a legal sentence can have many different things, and it's very, very hard to know how to label that. So what people have been doing a lot in academia is labeling them for different goals. One thing could be, for example, factual patterns in a case and compare those to the outcome. That's one way of labeling. Another way could be look at the individual sentences and look at the kind of role that sentence has. Is it analyzing a legal rule? Is it providing a fact? So that's kind of the research that's being done, but it's very hard, and creating those taxonomies on how to classify sentences and then doing that properly in the legal domain is very difficult, and I think that's one of the reasons why we haven't seen that many kind of hardcore legal AI applications so far. But I think it's coming, and people are really thinking a lot about how to do this in the best ways and the most helpful ways as well.
Maybe a more general form of my question would be, is AI at the point where the computers can read to infer the data set?
So I think when a person reads a sentence, not only is a sentence there for interpretation, but everything the person knows about the world as well. And the AI doesn't have that kind of complex models yet. And I don't think we're really close to that moment either. So when an AI reads a text, it sees the words, it can compare them to other words and other sentences, but this kind of thing that we do of inferring the meaning of those words, understanding what they're talking about, and comparing to our own experience, we're not there yet with AI, for sure.
Okay, one more comment, and then we'll. You want?
I was going to ask a question. Can AI machines?
Oh, okay. There you go. Sorry.
Talking about being paranoid. Can AI machine be hacked, or can they be converted into evil creatures? I mean, that opens up a whole can of worms, doesn't it? And.
So that's a very interesting question, and it really has two different kinds of answers. Okay. On one hand, you would expect that if a machine has acquired its model from data, that it actually is less likely than a computer software system to be hacked, because it's sometimes hard to understand what these models do, right? And so therefore, if it's a program, you have a smart programmer, they might find a way to alter things, right? But if it's inferred from data by a machine, maybe we don't quite know how to perturb it. So on one hand, maybe it's more safe, right, in the long run. On the other hand, there is some really interesting research, including some of it done in Canada by CFAR-funded fellows, that looks at what's called adversarial noise. That means you can take an image, let's say it's an image of a panda, you put in some noise that looks just like little dots, right? White noise. And then you get an image that to a person still looks exactly like a panda, but to a computer now it's flipped to be like a sloth. And the computer can be very confident in this flip of label. And so this is a phenomenon that it's quite worrisome, right? Because it shows you that there is a brittleness to these systems still. And it's something that is definitely at the forefront of, people trying to fix it now, or to at least understand where this kind of mistake is coming from. Maybe some of it is a lack of robustness that's due to some of this lack of common sense, right? We have some higher level understanding of the world that computers at the moment lack. They just look at data. They have access to a very large but limited amount of data, and they can get distracted by little correlations in that data that maybe are spurious correlations. But yeah, it's not clear where things will go, but there's very interesting work basically at the intersection of machine learning and security that looks at this kind of adversarial noise and how can we prevent these kinds of attacks.
It's along the line of what we're doing now to stop hackers. I mean, you mentioned participating in hackathon, I believe, earlier on. How do we ensure that hackers don't have a free a free meal? And the implications are scary when it comes to AI.
They are. They are indeed. Okay, so I'm going to. I've been charged with kind of trying to wrap this up. So I'll try. I'll do the best I can. You can mock me later. We're going to sort of a social event. You can mock me there. Okay, so yeah, so we talked a little bit at the beginning about mass production of machines versus customized productions. And at some point we talked about machines that do self-assembly. I found that interesting and worrying. So can they carry on without us down the road? You know, and there's the whole business about, you know, all the machines in our houses that are smarter and smarter, and there's your television listening to you and whatnot. I read an interesting thing about 3 or 4 weeks ago about, was a high school student, her mother took her phone away, so she wanted to make sure her friends knew why she had suddenly stopped being part of the social networks online, so she texted them using the fridge. There you go, eh? So, yeah. So yeah, and the need to have a good sensing ability, and then that's going to be processed, etc. It's to be output, so the machine can make decisions and have effect. Balance of AI, data. Well, this is data access. So some companies, I guess you say, some have more and others less, but I guess so far at least they're being reasonably good about sharing it. That's right. Yeah. Social side being addressed. We've touched on that quite a number of times here. I think and this comes back in some part to the fears. You know, what's this going to do to social structures, etc., and who's going to be serving who here in the long run? I guess is one of those questions that sits out there. There's a kind of, I guess we had some reassurance. There's been a benevolent perspective running through this at the research level, at least for quite a long time. But I guess I always worry about, you know, Airbnb started out as quite a sort of, or you know, the taxi services, all these things started out as kind of, we're all going to just help each other because I'm going somewhere in my car anyway, and it just became another taxi service. So there's some concerns about where we go with all this. Yeah, reference material, all the stuff that's online, that's where we all go now. And who controls that, I suppose, in the long run and all that. There was a question about plants. We'll talk about that later. Expert systems, are they as good as humans? And can they, I guess the thing that I was wondering about that was, can they be original? Can they actually do original things? That's that's a threshold. I don't think we've crossed that yet, have we? Or have we? Or are we on the edge of it?
In certain cases, they can be original. So this was documented, for example, in the Go Playing program,
so
that it can
with some original,
invent things
innovative moves.
Yeah, innovative moves that
There
people don't
you
have.
are.
And there's actually some people also working on AI and creativity. So AI's support for, let's say, visual artists, for musical artists, and so on. There's some element of that.
And then we got into algorithms and things like dating, jobs, all this kind of stuff. They're taking the place of some of the people who might have, some of the senior people in communities who might have advised people a generation or two ago. That's an interesting thing, and again, maybe concerning. I don't know, but yeah. So and then we got in the same way things like them overseeing legal decisions, surgery processes, all that kind of thing, making sure they're done best or they're done unbiased, potentially in elections and things, all that. So that's extremely interesting, but again, extremely far-reaching in terms of social impact. The unemployment issue, that'll be an interesting one. As somebody who works in agriculture, I mean, at the beginning, through the first, I know 2/3 of the 20th century, we underwent massive mechanization of agriculture. It used to be that 80% of people lived on farms producing food. Now it's 1 or 2%. I mean, everybody just moved into cities and started doing other stuff, or got around to eventually inventing smartphones and then AI. So there you are. So we'll see where it all goes. But it's not like we have been through waves of this kind of thing before. So, and then the business about fake everything. I guess it's a mixed bag. I mean, somebody could do something and make somebody who's socially influential seem to say something that leans one way or the other politically and tries to lead people here and there. So that's obviously a very real worry, and we need to be able to spot that kind of thing. On the other hand, we might get a new Marx Brothers movie soon. Could be exciting, right? So we'll see. Anyway, yeah. So and then I heard the term generative adversarial network. I'm going to introduce this into a party at some point and see what happens. And that's as far as I got in keeping notes. It was the last one I was, anyway. So okay, so that's kind of it. Do you guys have wrap-ups now? We've heard. Do you have anything you'd like to say, sort of by overall consideration, just here at the end now? Okay, we got.
Sure, I have two.
He does.
I do. I have two things I want to say. First, about hackathons. So hackathons is not really about hacking, but it's more about doing some programming. It's usually a programming competition for 48 hours, so it's not bad. And second, about AI and integration. I think this is something as you mentioned, it's something that's been going on for a long time, as integrating with our tools. Before, for example, we would have to tell each other stories to retain knowledge. Now we do that through books instead. Before, I needed to remember phone numbers, but that part of my brain has now been outsourced to my phone. And the same goes with finding. When I walked here, my phone told me exactly where to go, and I asked myself, how did people find before phones? But somehow people did. So that's I think this has been a trend that's been happening for a long, long time, almost like for thousands of years, us building tools and like integrating those into our lives. And I think that's something that will definitely happen more with AI because it's such a powerful instrument. But it's not really new, and it doesn't have to be bad. What I do think is worrisome to some extent is that the tools we use now have kind of a purpose. If I use a hammer, it's good. If I don't use the hammer won't come back to me to ask me to use it more. Whereas my phone, one of its purposes is to be used a lot by me. And many of the designs encourage that on my part. And I think this is something we have to keep in mind, that there's different interests at play here. And through AI, those can kind of be enforced and integrated. And that will, I think, affect society. So I think it's very important that we keep in mind who builds these tools and why did they build them.
Okay, Doina?
Yeah, so I really like what Hannah said. Just one thing that I want to add to that is, you know, a lot of the social issues that are being attributed to AI really have existed for a long time, right? And so this, for example, this issue of bias, right? And everybody's worried about bias in the data, but people are not as worried about bias in other people, right? Who maybe make decisions about you. Based on background information that they shouldn't be considering. So these are problems that are societal problems. And I feel that AI is shining a light on these problems. And that's not bad, right? Because these are problems that we need to reckon with, right? The stability of our economic systems and political systems and so on. That's just stuff that we need to be preoccupied by. And so, yes, AI is perhaps bringing that into focus. Perhaps it can be making these worse, but actually perhaps it's going to make them better also by making us think more about them. So.
Okay, so maybe at this point, if people in the audience, it's your guys' turn to sum up. So if some people, 3 or 4 of you have like sort of one sentence summaries about the key thing you took away from this, or the key thing that it affected your thinking from this, we'd be happy to hear a few of those. Anybody? Go ahead. Here, I'll bring you mine. I'm closer.
My takeaway is the concept of AI for good, and I think we started to uncover the AI for good piece. We're all well aware of the AI anxiety, but the AI for good piece is something that we should be emphasizing and exploring. The justice system, the medical things, there are several positive things there. And acknowledging that the AI so far has been driven by largely by commercial interests, and so yes, they're developing us to use the phone, to use the AI for those kind of things. But the AI for good piece is a thing I want to take away.
Anybody else? I'd be willing to do 2 more of those. Okay. Well, all right. So you go ahead. I'll hand this one in here. Here. Go ahead.
Okay. Well, I maybe just following on some of the last comments. You know, one of my takeaways is some of the anxiety that people have here in the audience about the technology, and my first reflection is we didn't need AI or modern technology to have a war 50 years ago that destroyed 20 million people. And I actually think that allowing technology to be a bogeyman maybe distracts us from our responsibility to look for the bogeyman independent of technology. We don't need AI fakes to lie to us. We already have plenty of examples of people lying to us, and we don't need to trust AI or worry about AI taking or robbing us of decision making and judgment, because people have shown themselves willing to do that in the past. So I think that people are right to be anxious about the future or just anxious about society and where it's going, but I don't think it should be perhaps just focused on AI or the evolution of technology. It's a constant in our lives.
Okay, my takeaway is a bit of deja vu. I started installing computer systems in the 70s in companies, and the big issue was, what's it going to do to the people? How are we going to lose the jobs? And here it's the same, this deja vu all over again. So it sounds familiar.
Okay, so at this moment, we'll have some gifts for these folks later on at the reception. You can all admire them. Mm-hmm. And but we at this point we have also have a gift for Monsieur de Grandpré, I mean, it's from our local Mac market. So this is agricultural stuff. This is okay. So and we also want to wish Monsieur de Grandpré a happy birthday on September 14th. He'll be 98. Yeah, that's exactly right. That's exactly right. You have a book coming, is that right? Did you want to I could hand you the microphone. You wanted to say something about that, or it's up to you.
Well, I think I'll use this one.
All right. Okay. Go ahead. Indeed.
You might be wondering why these conferences are held and why they refer to the conferences Jean de Grandpré. My association with McGill goes way back. My association with McDonald College also goes way back. And it all started because when I was a governor at McGill, I was on a committee that was supposed to look at the future of the institution. One report was that maybe McDonald College should be moved back to Sherbrooke Street. I was a member of that committee, and I said it doesn't make sense. And I issued a minority report. The Board of Governors approved the majority report. So it had to go to the Senate, and the Senate approved my minority report. That's why they love me here.
All right then. So yeah. So there's a reception just down the hall here. If you follow, for instance, Margaret, she knows the way. You could follow me too, but it might be a little more wandering. But anyway, so yeah. So welcome to the reception. But thank you everybody, and thank you to our two speakers, and thank you to Monsieur de Grandpré.